What are sunglasses? Sunglasses are a form of protective eyewear designed primarily to prevent bright sunlight and high energy visible light from damaging or discomforting the eyes. The first pair ever made. The first sunglasses were invented sometime in 12th century China. They were made to block out the light from the sun. These frames were roughly shaped to hold them against your face. These darkened lenses are made only for the very rich, but were not vision correct. They protected against harmful UV rays, but they provided some relief from having the bright sun constantly shining into your eyes, and were also used to hide emotions from others when speaking with them. This is an example or a picture of the first sunglasses ever made. Color-tinted lenses. Colors are caused by light with different wavelengths. Sunglasses that are tinted different colors have different effects on vision, based on which wavelengths of light they filter and how the brain interprets images seen through that color. Sunlight has equal amounts of all wavelengths of light, so when a tinted lens is used, it can show the different wavelengths of photo absorbed by the eye, thus changing one's vision. Why do we need sunglasses? UV light or ultraviolet light is damaging to the eyes. Sunglasses filter UV light, prevent it from reaching the eye so that it is not absorbed by the chromospheres in the retina. Sunglasses also reduce glare, which is extremely bright white light with a brightness over 4,000 lumens is harmful to eyes and is often considered a glare. Glare reduces the clarity and contrast of the image produced when light enters the retina. It is also uncomfortable to the eyes, and can prevent people from seeing properly. There are many types of sunglasses that vary in effectiveness and filter different types of light. Gold-tinted lenses. It eliminates most of the color blue, which is damaging to the eyes and has a low wavelength, while increasing other wavelengths of photons that are absorbed by the chromospheres, making images brighter and more distinct. Purple/rose-tinted lenses. It creates especially good contrast on a blue or green background. Green. Things that green tinted lens eliminates some blue light for the use, decreases glare, and also creates great contrast of color. Photochromic plastic sunglasses. A certain type of plastic is necessary to produce plastic photochromic sunglasses. It must be able to support the chemicals that react. Plastic prescription glasses use thiourea and polycarbonate to create thin lenses, which cannot support the photochromic reactions, as thiourea would attack and break down the dyes, while the reaction would occur too slowly in the polycarbonate. The photochromic dyes are protected by polyurethane and then placed between two other layers of plastic. Photochromic sunglasses have lenses that change from normal lenses to sunglasses lenses when exposed to sunlight. When plastic photochromic sunglasses are exposed to UV light, a chemical bond is broken in to become stable. The new molecule is rearranged in a way that makes it absorb longer wavelengths. The lenses get darker due to this reaction. Glass sunglasses. In glass photochromic sunglasses, a reaction between embedded silver halide crystals in the glass. Without UV light, the reverse reaction occurs. This is a picture of photochromic reaction. When a naphthopirin dye is exposed to UV light, a weak bond red breaks and the molecule rearranges. that absorb light at longer wavelengths. The example on the left absorbs UV light, and the bund on the right absorbs UV and visible light. Glass versus plastic. Glass is less popular, but it is more resilient against wear. It also lasts longer because it contains inorganic silver chemicals that do not break down, as opposed to organic compounds used in plastic glasses. How glass photochromic lenses work. When light strikes a silver chloride crystal, an electron transfer is induced. This is the reaction below. Silver atoms are formed within each crystal, and they migrate to the surface of the crystals. They form small aggregates of silver and light passing through the lens. In order for the process to be reversible, Cu ions are added to the glass matrix. They donate electrons to the chlorine atoms. The formation of chloride ions from the chlorine prevents the atoms from forming chlorine gas and leaving the crystals. If the process would be irreversible, sunglasses would stay darkened. When sunlight is removed from the process, the ions migrate to the crystal surfaces where the silver aggregates were formed. They accept electrons and return to their original state. All chemical entities return to their original state. Polarized sunglasses. Polarized sunglasses reduce glare. When light is polarized, its waves are aligned. To make polarized sunglasses, a chemical film is applied to the lens. The film is made up of molecules that are parallel to each other. This creates a filter. The filter absorbs all light except for light that does not match the orientation of the filter, which passes through and is polarized. Most light that produces glare is from horizontal surfaces, so polarized sunglasses only allow vertically polarized light to pass, reducing the glare. A little extra. How are people colorblind? Rods and cones in the retina convert light into electrical impulses. There are 3 types of cones: those that absorb green, L cones, red, M cones, and blue light. Colorblind people experience spectral overlap. The red cones absorb green light, or the green cones absorb red light, in addition to the default colors they absorb, and this causes the color to be interchangeable. They can't tell the difference between green and red, helping the colorblind see colors. The Chroma company has developed sunglasses that filter light specifically to remedy color blindness. They use a patent linear programming method that can create a unique filter for specific cases of colorblind. Notches are created where the red and green photopigments overlap. The overlap is the cause of color blindness. The notches reduce overlap of the signals of the L and M cones, increasing the ability of the eye to differentiate the colors. To conclude, presentation of the chemistry of sunglasses done by Jacoby Hartford. Hope you enjoyed the brief presentation I have provided with the hard work and long nights I have put into this project. Smiley face.